Hi, in this video we will talk about the ARMA PQ forecasting formula, which is a big looking formula. The good news is we're not going to have to calculate that by hand. We're going to let R do it for us, but let's have an idea of where that comes from, and you'll see that if we'll start with the AR1 and the AR2 and the ARP, moving up to the ARMA PQ is not really a huge stretch from there. All right, so we'll do exactly that. The AR1 model, let's start there. That's this upper left little piece here. And remember that an ARMA model can be written as x sub t equals phi1 times x sub t minus 1. There's the lag 1 that we're expecting from an AR1. I'll go back one time point, plus 1 minus phi1 times mu plus this error term a sub t. That is the AR1 model, which by this point in the book we've seen a few times. Now, what about the AR1 model forecast formula? Well, remember that to get the formula for the forecast, all you do is look at the AR1 model. Everywhere you see a phi1, replace it with phi1 hat. Everywhere you see an x, replace it with x hat of t naught of L minus 1. Let's take a quick little time out here and back up. I said these are the forecasts. I didn't really give the notation here. Let's review the notation. Remember, this means x hat, that's a prediction, of t naught. T naught is the last term in a data set. So t naught is the nth term, nth data value. Now, the L are the number of steps ahead. So x hat of t naught of L means, assuming the data set ends at time point t naught, L steps ahead, then your forecast will be phi1 hat times x hat of t naught, same concept as before, of L minus 1 plus 1 minus phi hat 1 times mu. Well, mu gets replaced by x bar plus, what about a sub t? Well, recall that AT is assumed to have a mean of 0. So our best guess, our best forecast for a sub t for any given t is just going to be 0. So that disappears. And that is our forecast formula for an AR1 model. Let's extend to an AR2. What about an AR2? Again, let's write out the model form of it. And all we're doing is just throwing in an extra term for the phi2 and the xt minus 2. So that's what we do here. If xt equals phi1 times xt minus 1, that's the lag 1 piece that we saw back in the AR1, plus, here comes the new part, phi2 times x sub t minus 2. That's saying go back 2 time points ago and multiply by this coefficient phi sub 2, and that's supposed to be helpful for finding our x sub t. And then what about this, this mean term? Before it was 1 minus phi1, now it's going to be 1 minus phi1 minus phi2 times mu plus the error term of a sub t. Well, how would the forecast formula be in a case like this? Very much like it was before. Phi1 will get replaced by phi1 hat. Xt minus 1 will get replaced by x hat of t naught of L minus 1. Phi2 hat, x hat of t naught L minus 2 plus, and then as we did last time, we will have this mu will get replaced by x bar. So this is going to look like 1 minus phi1 hat minus phi2 hat times x bar. And that's the formula for the AR2 model forecast formula. Okay, let's extend that. What about the ARP? Well, the same type of thing. Instead of there being a phi1 and a phi2, it'll go out to phi p. So we have phi1 times xt minus 1 all the way out to phi p of xt minus p. Plus the mean term will be 1 minus phi1 minus all the way out to phi sub p times mu plus at. And then another way to write that, and the reason I want to write it in this form is because our ARMA PQ formula to match the text right where we are in this, where this QR code sits in the text, it's in this summation form, and it's just more convenient. The ARMA PQ is big, so we often write it in this form. So we could rewrite this ARP as this summation form where you've got x sub t equals summation of j equals 1 to p times phi j times xt minus j plus mu, and then this bracket of these different phi values plus a sub t. So no harder than the line before, just in a little bit more convenient notation. All right, now what would the forecast look like for this? And we'll go ahead and use this summation form in order to write these forecasts out. Again, x hat of t naught of L will be the summation of j equals 1 to p of phi hat j times x hat of t naught of L minus j plus mu will become x bar. I know we moved that up to the front from last time, but that's okay. That doesn't matter. X bar times 1 minus j equals 1 to p of phi hat j. And then the AT is expected to be 0. I don't know about expected to be, but it's forecasted to be 0. We know that the mean would be 0. Okay, so that is the forecast formula for an ARP model. Now, why would I do this? That's not the title of this video. This video is supposed to be about ARMA PQ forecasting. Well, I think I've got us in a good position, because if we understood our review of the AR1 model and its forecast formula, the AR2 model and its forecast formula, and the ARP model and its forecast formula, we're not far away from being able to understand the forecast formula for the ARMA PQ. That's what we'll do on the next light board. Okay, let's continue where we left off here, and remember that we talked about the AR1, the AR2, and the ARP. Now let's extend that to the ARMA PQ. The first thing we've got here is the formula for the ARMA PQ model, just the general form. And recall that the difference is you've got this Q. We haven't been talking about Q's. Everything was P. The Q term represents the white noise terms, the error terms. And it's written here as x of t equals, big looking formula, but it's at least patterned. Beta, we'll talk about beta in a minute, plus phi1 xt minus 1 plus phi2 xt minus 2 all the way out to phi p xt minus p. Now that's the ARP part. And then, or plus this AT, that gives you the AT part. Okay, continuing where we left off, where we had talked about the AR1 and the AR2 and the ARP, let's now extend to the ARMA PQ. Remember that the ARMA PQ adds the Q term, and that really represents the error terms. So you're going to see more about the AT. Recall that in the ARP, we just had this one AT, this error term, and now we're going to look at that in more detail, where we're looking at previous values of the error terms. That's the difference between the AR and the ARMA. So the form is x of t equals beta, plus, we'll talk about beta in a minute, phi1 times xt minus 1 plus phi2 times xt minus 2 all the way out to phi p times xt minus p. That's the ARP part coming in, plus the AT. Then we've got this minus not phi, but theta. Theta 1, that's the new parameter for the Q terms, for the MA terms. Theta 1 times AT minus 1, not XT minus 1, but AT minus 1, minus theta 2 times AT minus 2, all the way out to theta Q times AT minus Q. That is the general form, the written out form of the ARMA PQ. Let's talk about a few things. Beta, you remember that's not exactly at all what we saw from the AR. So what's this beta? Well, it's just a different way to say the 1 minus phi1 piece. So the beta is the 1 minus phi1 minus phi2 alpha minus phi p mu. So it's the mean term. And so we put that here at the front. That's the betas. What's AT? AT is what it has been. It's white noise with zero mean and finite variance, sigma squared. The phi k's, obviously, as we said, are the AR parameters. The theta k's are the MA parameters. K goes from 1 to P, and K goes from 1 to, or for the AR, and K goes from 1 to Q for the MA. And that's how it gets its name, the ARMA PQ. Now, that makes our forecast formula for the ARMA PQ pretty straightforward, simply because we've already done this for the AR1 and the AR2 and the ARP. So it's not that big of a jump. So what would you do? Well, you would come in and say that for the theta, and we're going to put this in summation form, x hat of t naught of L is the summation. We'll do that. This is going to be the AR piece at first. And that will be what? Well, we'll take each of these phis, whether it's phi 1, phi 2, all the way out to phi p, and we'll put hats on them. There's the phi hat j. And then what about the x terms? That's the xt minus 1, xt minus 2, out to xt minus p. X hat of t naught of L minus j, where j goes from 1 to p. And that takes care of this piece right here. And then we've got this part about the minuses come in, and it's minus the theta terms. So we have minus j equals L to q of theta hat. So theta 1 is going to get replaced by theta, so that needs to be a j. So this gets replaced by theta hat, and the a's will get replaced by a hat of t naught plus L minus j. And then we've got this beta term, and beta was made up of these 1 minus phi 1 minus phi 2 out to phi p times mu. Well, we know the mu is going to get replaced by x bar as its forecast, and then we have 1 minus the summation from j equals 1 to p of the theta hat j's. And that is the forecast formula for the ARMA PQ model. So as I said, if we're given that this is the model that for the ARMA PQ, and we've known that based on the writing of the chapter, then the forecast formula is not surprising. I didn't mention this, but what happens to the A sub t? Well, the AT has 0 mean, so that's why it completely goes away. So I'm going to go ahead and scratch that out. Everything else is accounted for because here is the MA piece, here's the AR piece, and then the beta piece is right here. So yes, that's the forecast formula for the ARMA PQ model. As I said, that would be very tough to calculate by hand. That's not the expectation. That's not a good use of time. So we'll have R do it for us, and I've included the syntax there for TSWGE. Straightforward for us, right? R can deal with the issue of calculating this, but I'm just labeling it forecast. Forecast equal, here's the syntax. For, F-O-R-E, dot ARMA, dot WGE. The arguments would be give the data set, then give the phi values, phi equal, so there's the AR term, the AR terms, and then the theta values, that's the MA terms. N dot ahead would be the number of forecasts, and then the limits either would be false or true, depending on whether you want the limit lines or not. And we'll see in an upcoming video how we actually put this forecast function into place on a real data set.